Right, so here's the setup that we're going to create. So we have a Pfsense firewall here. It has 3 connections. One is to the public network, one to private, and one to DMZ. The public network will be on DHCP, gets it from this gateway, and the private network will be in 10.10.x.0/24, and the DMZ will be 10.10.y.0.24, where X and Y are 2 different networks that you're allocated. For the private network, the default gateway in this case will be 10.10.x.254, and the host, Ubuntu host, will go at .7. On the DMZ, we will place the hosts at .7, .8 and .9. That's for Windows, Kali and the Metasploitable instance. These machines will use this as their default gateway, 10.10.y.254. Ubuntu will use this as the default gateway. What we'll do to configure the firewall is that we'll only enable one of the ports, this one here, and allow us to be able to log in from a web browser into the firewall and then configure it. What we'll find is that anything on the private network is allowed out anywhere, but the DMZ will not be allowed to do anything at all until we open up the firewall. Okay, so let's make a start, and we'll start by booting up our Pfsense firewall. Okay, so we'll just power it on. So I'm going to use 20.20.20.0 for private and 20.20.21.0 for the DMZ. Okay, so it's just booting up just now. So we should get it started. And remember, we only have to configure one interface. So we'll say no to VLANs, and we'll go for the default names for the interfaces of LE0, LE1 and LE2. That looks fine. We've got the WAN on LE1, the WAN on LE0, LAN on LE1, and opt1, which was the DMZ, is on LE2. So yes, we'll go with that, and the firewall will be getting configured. So now what we need to do is to be able to set up the LAN interface to be 20.20.20.254/24. Okay, and then once that's set up, we'll go and log in. We'll set up the Ubuntu machine, and we'll log in from there into the firewall. Okay, just takes a little minute, and that's us started. So we can see that we've been given an IP address on the public interface of 10.221.0.18, but our LAN interface isn't set right. So we'll go to LAN, and we're 20.20.20.254 for the firewall, and 24 bits, no default gateway, and no DHCP. Now it'll ask us where we want to configure it from, and we'll say yes, we'll use HTTP for that. And it should tell us what the IP address is that we connect to. That will only be on the LAN port that we can connect. So 20.20.20.254 will be our configuration place. Okay, so that's fine. So now what we'll do is we'll go to our Ubuntu machine. Already got this started here. And we need to set this up as 20.20.20.7. So let's see what our IP address is. Okay, and we can see the interface is down just now, so we need to bring it back. We need to bring it up. Sudo IP link set ENS32 is the name, and that's fine. So I need to do IP. Keep doing up. Okay, so hopefully we should see that as up now, and it is. So now we'll set the IP address of the interface to be 20.20.20.7 20/24 dev for ENS 32. Sorry, it should be IP. Okay, that's fine. Now we'll set up the default gateway. So we need to do IP root, add default via 20.20.20.254 and via ENS 32. Okay, everything's good, so let's try pinging ourselves. Pinging the default gateway, that's good. And ping Google, yes, that's fine. But we should find that when we ping google.com it won't work. Oh, it does. And the reason that it's working is that hopefully we've set up our resolve.conf with the right address. So if this isn't set up right, you need to change that to 10.221.3.254. It's set up so it means that we can actually ping and we can do an NS lookup on google.com and it should work. Okay, so that's our host set up there. Now what we'll do is we'll set the other hosts up. So first I'll go to my Windows 7 machine. This is .7 that I need to set up. Network properties. There. There we go. 10. And I'm going to set up 20.20.21.7. It's already set up for me. And that's default gateway, and that's the DNS there. But what we'll find is that we can't ping anything yet. And the reason we can ping ourselves, but we won't be able to ping the default gateway because it doesn't actually exist yet. We'll go and set up our Kali machine. Okay, so Kali on the DMZ. Okay, so we'll just see what address it's set up for. Okay, no address, so we'll set that up just now. That's 20.20.21.8. That's fine. And then we'll set up the default gateway, which will be 20.20.21.254 via ETH0. Oh, forgot the via. Okay, we can have a look at our root just to prove that where our default gateway is, and we can see here that our default gateway is at 20.21.254, which doesn't exist yet, but it will soon. Okay, we should be able to ping the Windows machine from here because it's on the same network, so everything should be fine. Okay, that's great. And then we'll go and we'll set up our Metasploitable instance. Okay, we'll just have a little look to see if this one is set up for us already. And for ETH0, we need to set up our IP address. Okay, so we'll just set this up. Add 20.20.21.9/24 and it's ETH0. And now we'll set up the default gateway, IP route, add default via 20.20.21.254, device ENS32, ETH 0. Okay, so hopefully we'll be able to ping the Windows machine and everything's good there. Okay, so what we won't be able to do is to actually connect anywhere because the firewall port hasn't been enabled yet and the firewall hasn't been opened. So we'll go back to our Ubuntu machine and hopefully we can ping our default gateway. Okay, so from here what we'll do is we'll open up the firewall for a connection. So 20.20.2254, that's great. And then we'll log in. Okay, so this is in. So the first thing we need to do is to be able to create the interface. We'll give it a name of DMZ if we want, and we need to give a static IP address. Here, and the address is here. 20.20.21.254, and remember we need to put a subnet mask of 24 bits. Our default gateway will already be set to the main default gateway, so everything is fine there. So we'll apply that. Okay, then what we should find when we look at our terminal for the firewall, just refresh it, we can now see that the IP address has been set for the DMZ. So everything should be good now. We now have the firewall set up with all its interfaces and so on. Okay, so one thing we can do is go to diagnostics, look at our ARP table. So this is often used to be able to find out what devices are actually connecting to the firewall to make sure that all our network connections are correct. So if we look down, these are the ones here. So there is the MAC address of the gateway on the LAN, and here is the MAC address of the Ubuntu machine. So we've got an E9 at the end. Hopefully if we look at our interface, we should be able to see that it's E9 for the MAC address there. Okay, so these are the MAC addresses that have been discovered. We can look at that MAC address and hopefully that one should relate, 51 should relate to what's here, and we can see that's the case there. Okay, we can also look at another diagnostic, and that's to do with the network packet capture. Okay, so diagnostics, and we go to packet capture. So we can sit on any interface that we want, but we'll sit on the LAN interface. And then what we'll do is we'll capture our ping packets. So we'll select ICMP and we'll start. Okay, so we should find that the firewall is now capturing packets on the LAN for ICMP. Now we'll go back here and we'll do some pinging around. So we'll ping the default gateway, we'll ping Google, 2, 3, that's fine. And then we'll stop here. And now we'll just have a look to see what we got. And there it's there. Okay, so there's my ping of the default gateway. We have a sequence number which should tie up with the request and the reply. And here is my ICMP from the host, Ubuntu host to that. If I want, I can download the capture as a pcap, and that will be it. One thing we can't do yet is to ping anything anywhere because on the DMZ all ICMP, in fact all traffic is blocked by the firewall. So if I try to ping even the default gateway, although it's there now, then it won't actually go through. Okay, so what we'll do next is that we'll enable some rules to allow the traffic to flow. So we go back to Ubuntu. We'll go to our firewall rules, and we'll see that the LAN has got a default rule that allows everything. That's why we can ping and connect to Google, but the DMZ has nothing. So we'll add a new rule, and what we'll do is we'll add ICMP first. So protocol ICMP, and I'll just allow it to go anywhere. We can allow it to go to certain hosts or to certain networks, but I'll just allow all ICMP to flow through. Okay, so I'll apply the changes. So now, when we go here, we can now ping the default gateway, and we should be able to ping the Ubuntu host and also Google. Everything is working here. One thing that won't work is google.com, but I'll explain that in a little minute. So we try the Windows machine, ping 10.20.20.20.254, that works perfectly, and then we try the Ubuntu machine, and again that works okay. So everything is now working for ICMP, but one thing that isn't working is our DNS. So what we'll do to make the DNS work is that we'll enable port 53 UDP on the firewall. Okay, so we'll just go back here, and we're going to add, and we want UDP from anywhere to anywhere else, and we want it to go from 53 to 53, and so this should enable our DNS to work for the DMZ. Okay, so now when we ping Google, it magically works, and when we do NS lookup, that also works. Same again for here, for the Windows machine. Then when we ping Google now, it works, and our NS lookup should work too. That's great. But now when we try to connect to the internet, then we should find that we can't connect. The reason for that is that TCP traffic is blocked on the firewall. So just let this open here. So if we go to google.com, say, then nothing appears because it's blocked. So we'll go back to our firewall here, and we'll add in a new rule. So one thing that we can look at over here is that when I do an nmap for the machine on the other network, then we should find that we don't get any ports coming through because they're all blocked on the firewall. But when I look at Ubuntu and I do an nmap against the Windows machine, then this should give me all the ports that are open there. Okay, so you can see the Windows machine hasn't given any ports, but the Ubuntu machine has. So what we'll do is we'll open up all the TCP ports on the firewall to make sure that it's allowing TCP to go through. So allow TCP any port to any destination, and we can save that from there. And then we just check our rules. TCP is allowed, ICMP is allowed, and port 53 is allowed. So now when we go to our Windows machine, hopefully we should be able to do an nmap. There we go, it's working perfectly, and I should be able to connect to Google. Perfect, that's great. And we should be able to connect to the Ubuntu server .7. That's great, and we should be able to do that vice versa. We should have always been able to connect to each of the hosts on the DMZ and without the firewall, but we'll just check. So 20.20.21.8 is Kali and .9 is Metasploitable. Okay, so it's all working now. We can actually see that the whole network is connecting. Now what we'll do is we'll run nmap against Metasploitable. So the Metasploitable instance is at 20.20.21.9. Okay, so here are all the services on Metasploitable. And then we can go to Ubuntu and hopefully this will work. We're going to nmap 20.20.21.9 and that's what works there. So there's lots of services on Metasploitable which we'll connect to in a little minute. Okay, so from Windows, what we're going to do is we're going to investigate Telnet. So we'll find that Telnet is an insecure protocol. So first I'll run Wireshark here, if I can find it. And then I'm going to Telnet into Metasploitable. Okay, we just need to find our interface. It looks like it's that one. Okay, so I'm going to Telnet into Metasploitable, which is 20.20.21.9. Okay, MSF, admin, and password there. Okay, so that's me logged in. I can do some commands and then I'll exit. Okay, so I'll just stop that. And we're looking for tcp.port equals 23. And here is the connection here. There's the SYN, SYNAC, and ACK, and then these are all the packets that are associated with the Telnet session. The quick way we can do this is to be able to just go to our session and then just do follow stream. Now we notice that we can actually see all of the text, including the password that was entered and all the details and all the text that came back. So we can actually see that Telnet isn't protecting the data at all for the connection. So now what we'll do is that we'll now use SSH. So we'll log into SSH, and it's 20.20.21.9, and the user is MSF admin. Oh, sorry, let me start my Wireshark first. Okay, so we'll just do that again. I'll log in with SSH, do some commands I did the last time, and I'll log out. Now we stop and we do tcp.port equals 22. Now we see lots of encrypted packets there. We still see the SYN and the SYN-ACK on port 22, but now when I follow the stream, we'll see a little bit of the handshake in terms of the SSH, but after that, this is what encrypted traffic kind of looks like. You can see it's all garbled there. So in this case, SSH is creating a tunnel for the connection, and even though we listen to network packets, we can't actually determine them. Okay, so that's showing you how the SSH can actually protect our data. Okay, so in the next part, what we'll do is that we'll run Wireshark again, and then we'll do an Nmap scan to see what we see on the host. So we'll start from Ubuntu here, and we're going to do an Nmap into the Windows, Windows. Okay, so we're going to Nmap 20.20.21.7. Just takes a little minute. You can see it's gone all grey and all red and so on, and that's it. Okay, so we'll just stop that. So just so that I can find the traffic, so let's actually just look at our own address, 20.20.21.7 for the filter. And this shows here what the Nmap scan actually looks like. What we see is lots of SYNs going through. See, and SYN and resets and so on. So this sends what's called a SYN flood to the server, and it will try to connect on all these ports. Some of them come through as connecting, so we'll get a SYN-ACK and an ACK coming back, where other ones will not connect and we'll get a reset. So the one with the SYN and the ACK here has been a successful connection, so that's why we see port 80 appear here, where other ports such as a 443 actually get a reset ACK. So whenever we see a reset ACK, it means the port is not open on the server. Whenever we get a SYN-ACK, then it's opened. If you want to actually have a look at this, then we can do tcp.flags.syn equals a 1, and here are all the .syns, and these are all the ports that are being connected to. And if we want to find an ACK, then we can say tcp.flags.ACK is equal to 1. And these are all the ports that are open on the server because they got reply back 80, 139, 587, 135, 23. There we are there. So 135, 139 should be another one, 445, then it's there, and so on. So the way the Nmap discovers that the ports that are open is through the SYNAC being replied back from the server. In this way, Nmap knows that that port is open. If it's blocked by the firewall in between, then it's not possible to connect to it. And the same can happen over here. So what we'll do is that we'll run Wireshark here. Okay, and then we'll do an Nmap of 20.20.20.7, which is the Ubuntu machine. It's quite quick, and then we'll stop that. So again, what we should see is lots of these SYNs coming through. Again, I'll just go for the address of the machine. 20.20.20.7. There we go. And then we should see lots of these SYNs and SYNACs and so on. So again, we can do a tcp.flag.syn equals a 1. tcp.flags. And there are all the SYNs. And if we want to have a look to see where the SYNACs came through, then we can do ACK equals 1. And so the ports that are open, 443, 21, 80, 12, 1723, and there's 1723, there's 80, 21, and so on. Okay, so that's the way that Nmap actually works from there. Okay, so we can go ahead and we can do some discovery of the ports that are running. If we do netstat -a here, we should be able to see the ports that are open on the server, and that should tie up with what we've seen with the Nmap. If a port is listening, it means there's a server port waiting to be connected to, and then these ones are the established connections that we have with the network. If we go over here onto our Ubuntu machine, let me just close this. Over here on Ubuntu, we can do netstat -l, and we can scroll up to see the TCP ports which are being listened to. Okay, so these are all of the server ports that are being listened on. Okay, so as I showed before, if we go to the web server on the other side, we should be able to see that service. So 20.20.21.7. That's the Windows server. But we can also use a telnet connection. So from the LAN, rather than using the web browser, we can use telnet 7, and we can put the port number 80 will connect to the port 80 web server. We then type in get / and it will return back the web page. So this is equivalent to what the web browser does when we connect. Again, if we connect to telnet 20.20.20.7 on port 80, okay, we do get / and then that returns back the web page from the Ubuntu server. So again, we can do this for FTP. So we'll start from over here this time. So then we want to connect to the FTP server. So the commands that we use are user and APR. As for the password, AP123, and that's us successfully logged into the FTP server. We can do the word present working directory, and it tells us where we are. So we just quit and exit. So these would be the commands that would be passed inside a graphical user interface for FTP, but we're just assessing them now with our telnet connection. And then we'll do the same. I think Windows is running an FTP server, so we'll connect to the Windows machine, and it's user Napier pass Napier. Let's try again. I'll try. Oops. User Napier pass. And that's us logged in now. Okay, we can do that again. Just let me take a note of that. And I'll quit. Okay, so in this way we can actually assess the services that we're actually running. Now what we'll do is you should see that there is a VNC connection running when we do our nmap. Then one of the services that's running on Ubuntu, sorry, if we do an nmap, here we see that VNC is running. So what we have is we have a VNC connection, which is a remote desktop connection. So we'll connect to 20.20.20.7 and a password of Napier. And what we should see is a screenshot of the remote connection. So VNC allows you to create a remote desktop connection into the server, and you can see that it's quite weak, that it just has a single default password. Okay, so now what we'll do is we'll move on to the next part of the lab. Okay, so in this part we'll run some nmap into some discovery points. So that's from Ubuntu. Run sudo nmap -sp -r10.221.0.0.24. Okay, so this is going to scan part of the public network to see which IP addresses are live on the public network. It'll take a little minute to scan, but we'll let it go through. So these are the ones that is discovered, and those are the ones that are on the public network and alive. Next, what we'll do is that we'll scan for the hosts that are on the DMZ and the 24 subnet mask. So this should just discover Windows at .7, Kali at .8, Metasploitable at .9, and the default gateway on that network at 254. Okay, so we can see it's a very useful method to be able to discover the hosts that are on a certain network. Okay, so we're going to run Wireshark here, and we'll just have a look to see what we get when we run this scan again. So I'm going to capture here. scan again. So we're going to scan the DMZ first. It's 20.20.20.21.0.24. Okay. So what we see straight away is lots of pings happening. So we'll go back here and we'll just get our address. Okay, so those are a few DNS calls. But what we see is ICMP ping packets being sent out to lots of addresses on the other network. So there's 20.20.21.199. So we can see that the way the Nmap is working here is that it sends out ping packets across the network. But watch what happens when I scan for the local network. So if I scan the local network, I should only pick up 2 hosts that are alive, the Ubuntu and the default gateway. Just takes a little minute. Okay, so you can see that we have a different scan this time, and we get DNS requests here for that one. Okay, so one thing that we can do is we can try and discover the operating system of a server. So we'll nmap with a -O for 20.20.21.0, that's 24, and this will hopefully try and discover the operating systems of the hosts that are on the DMZ. Just takes a little minute, and you can see all the traffic that's being generated by it. Lots of traffic created, lots of scanning and probing. So just quit that just now. Okay, so in this case it's discovered a Linux machine, and there's the gateway. It's discovered 2 ports that are running there, DNS. For the Linux machine, it's found it's a Linux kernel, and it's Ubuntu, and that relates to our Metasploitable instance there. For Windows, it's discovered that it's a Windows machine, one of these, and then for our other ones, then has it discovered Kali? Kali should be a .8. He didn't manage to get Kali. Kali's managed to cloak itself quite well here, so it didn't manage to pick up at that. Okay, so if you do the same for the Ubuntu, you should be able to get that to work.